Hello and welcome to this Tech Talk session that is all about the new HP TippingPoint Advanced Threat Appliance. My name is Angelo Brancato and let's get started. HP TippingPoint solution portfolio is very focused around real-time network defense and premiered in 2001 with the world's first commercially successful network-based intrusion prevention system, and is since then leading the industry in protecting against well-known and especially against yet unknown attacks against software vulnerability, so-called zero-day attacks or zero-day exploits. Whereas the new Advanced Threat Appliance is focused on yet unknown malware, which is a very important aspect in fighting against sophisticated and targeted attacks. Now one could ask, isn't malware and exploit the same thing really? Or in other words, why do we need an ATA when we already have a next-gen IPS or a next-gen firewall? Well, the answer is of course no. They are not the same thing and highly complementary. The ATA can detect static malware. Malware is software that is defined by its malicious intent, and it needs to be executed on the target host in order to do its thing. The IPS, however, can detect and block attacks on the network in real time that are aimed against a vulnerability in corporate software. Okay, now let's see what the ATA really is and how it can work hand in hand with the next-gen IPS and next-gen firewall. Let's also group the fight against malware in three main activities: detect, analyze, and respond, whereas the ATA does detect and analyze, and the IPS next-gen firewall does the response. First of all, the ATA needs to see all relevant network traffic so that it can send suspicious objects into a sandbox environment to automatically execute them and to analyze their behavior. An object could be an executable, a document, an email, or whatever communicates via 87 plus supported network protocols on any network port. The sandbox itself can be customized to represent the company's standard operating system with all corporate applications installed to simulate an actual client system in your environment. Once the new piece of malware got identified, the ATA will automatically send actionable intelligence like the malware's command and control IPs and domain names to the next-gen IPS and next-gen firewall, so the functionality of the malware can be restricted by cutting off its communication in real time on the network and thus preventing sensitive data exfiltration and preventing the real incident and giving the security admin enough time to clean out the patient zero infection. And of course, this actionable intelligence can be and should be distributed to all next-gen IPSs and next-gen firewalls to also protect distributed network segments or locations where no ATA is installed locally. Okay, let's see a more technical network diagram that has a perimeter, a core, and a distribution layer, and some branch offices attached to it. First of all, we define our security zones that can be formed with next-gen IPSs and next-gen firewalls. Then we have to place the ATA on a strategic point where it can get traffic from all network segments replicated via mirror ports. In this example, we have two mirror ports on the core switch that copy all network traffic to the ATA. As soon as malware is identified, the ATA will send that information to the SMS, which again distributes it to all devices that are distributed all over the network. So all next-gen IPSs and next-gen firewalls are aware of this new piece of malware and its behavior in calling home. Now let's say you have a mobile warrior that got infected on the road and connects to the branch office's network. The malware will immediately try to phone home, and with the IPS event you immediately have an indicator of compromise for that host. And of course we need to turn that information into intelligence to A, make sure that we see and fully understand all past activities of that infected host and what other systems it may infect it, and B, to make sure it doesn't happen again. To achieve this goal, all mentioned devices, the ATA, the next-gen IPS and the next-gen firewalls, are in fact able to send their events to the HP ArcSight logger and or security information and event management solution via the common event format. Okay, now that we have a rough overview of what the Advanced Threat Appliance does, let's see a live demo. In this demo, we use a pretty common approach of the attackers to infiltrate the corporate network and exfiltrate valuable data. The attacker social engineers its victim and sends a spear phishing email with a link to the malware. The individual clicks on the link and gets infected. So the attacker can remote control his victim and find and exfiltrate valuable data assets. For this demo, we will create a dropper executable and inject it into a PDF document that is linked in the spear phishing email. By reading the PDF, the dropper loads and installs the Trojan malware on the victim computer. Without the depicted solution, the attacker would have all time in the world to find valuable assets and exfiltrate them. But we want to be aware of the breach in this point in time to prevent the incident. Okay, let's get started. What you can see here is the victim host with its email client opened and the spear phishing email got in. And what you also can see is that I faked a little bit here the PayPay logo. And if you hover over the link, you can see at the bottom left that the link is pointing to a PDF. And that is the PDF that has the dropper executable in it, which will download the Trojan horse. Now let's create that executable. And for doing so, I'm using AutoIt or AutoIT because, yeah, it's just too simple to resist. So first of all, I'm including the WinHTTP library to do an HTTP GET, and the Trojan horse is placed on that domain, paypay.com/malware/malwaredb, and so on. So I will get that. I will write it to the local file system on ctemp. Then I will execute it, of course. We'll give it some time to do its thing. And then afterwards, I will delete it. And all I have to do is to compile it and make an executable out of it by clicking here. Okay, here we go. Now we have the dropper executable. To inject the dropper executable into a PDF, I will use the Metasploit framework. And within that framework, I'm using the Adobe PDF Embed exe module. And I give it as an input a clear PDF, which is called dinkycar.pdf. And as the executable to be injected, I will give it dinkycar.exe, the one that we just created. After doing so, I just say exploit and voila, here is my evil PDF. And I will also do some basic social engineering for beginners. So I will rename evil.pdf into transaction code or transaction details, transaction details.pdf. Okay, here we go. I will place that onto the web server where the email client, the link in the email points to, right? So it's paypay.com/transactiondetail.pdf. I already did that. Of course I did. So I will click on the link. I will open the PDF. And I want you to pay particular attention here on the Explorer, which points to ctemp. So I expect that as soon as the PDF gets opened, the Trojan will be downloaded, executed, and deleted afterwards. So let's click on it. And it wants to save the PDF to the local drive, of course, why not? Let's save it, yes. And let's look at here. You see the Trojan is here on the temp folder, gets executed and deleted afterwards. Voila, the PC is infected now. Now let's log on to the HP TippingPoint threat appliance. And we will jump directly into the virtual analyzer. And sure enough, it got the Trojan executable and it detonated it into the sandbox Now let's see the details. So what you can see here is the connection details. Basically, the Windows XP client downloaded that Trojan exe from that web server, which is all in my lab environment here, of course. So that's why you see private IP addresses. So that's the URL that we hard-coded into our little AutoIt dropper application. So let's go into the file analysis report, and of particular interest are the suspicious network or messaging activities here, which are a bunch of domains and IP addresses. So that's basically the communication attempt from the Trojan to the mothership, the command and control server. So we expect those items to be synchronized with our TippingPoint SMS. Now let's go to the TippingPoint SMS and see if they got feeded into the reputation database as user-defined entries. And sure enough, here they are. We can also search for them by deselecting the reputation DV entries. So those are the TippingPoint provided reputation feeds. And let's select user entries, click on search, and here we go. So all those domains will be blocked proactively by the next-gen IPSs or next-gen firewalls. And of course, not only your next-gen IPSs and firewalls should send all system event logs to your SIM solution, preferably ArcSight, but also the ATA. So let's check if that's the case. Logs, system log settings, and sure enough, it will send on the events via Ceph to a smart connector. And let's go into our SIM tool, and on this dashboard you can see suspicious hosts that are propagating malware. Now let's double click on that host here, which will open an active channel. With all base events. Now what's extremely important is that we not only want to block the communication to the command and control server, but we also want to quarantine that particular host as fast as possible. So we can do that automatically or manually with the ArcSight SIM solution. So I will do it manually now. I will click on the host's IP address, right click, I'll select integration command, and I will put that exact IP address into a quarantine so that all communication from and to that IP address gets quarantined, and I get time to clean up the system. So if we go back to the TippingPoint SMS on responder, you can see the quarantine action that we just launched via the ArcSight TippingPoint integration so that we quarantined that infected host. And with that, I win, and you, bad guy, you lose because you didn't get to exfiltrate my data. Now, as we said before, we not only want to prevent the incident, but we also want to do some forensic analysis. So we are going to open another active channel. Let's search on that IP address. So I just created a filter that says target address equals the host's IP address. I will edit the search criteria and add attacker address 10.0.2.56 and make it an OR and click on apply. So I get all communications from and to that IP address of that infected host. Now let's go ahead and select all and create a little event graph. Because as we all know, a picture tells more than 1,000 base events. And so I can see to whom that client communicated in the past. And of particular interest is maybe here that little FTP connection to that FTP server. And if I wanted, I could drill down and see some S-flow event and really get a good idea of what that client did in the past. Thanks for watching and talk to you soon. Ciao.